Hello there, and welcome to another exciting episode of Arthur Does Math, where you sit here and watch me do math because your grade depends on it. Welcome. Today we're going to talk about graphing sine and cosine, and I am going to try and keep this video as brief as possible. Bear with me on this section. I do just want to give you a warning. It takes some practice, so if you're a little frustrated at first, please watch the video again, pause it, talk to your friends, make sure you're processing the information that's going on here. So I want to start out by just talking about what does the graph of sine and cosine look like. And in following these guided notes, you can already see what they are. They're given to you here. If I were doing this on the board, I might create them myself. But both of them have this wave pattern going to them. And actually, they are identical graphs, just one is shifted slightly. Okay? They have the same height, the same repeating. We'll get to some vocabulary here in just a second. But they're pretty much identical graphs that are just shifted. So the sine is here on the left and the cosine's here on the right. Now, this is the graph of, we're graphing the y values of the sine of x, where x is an angle, and we do that angle measure in radians. So that's something worth writing here, that this x is an angle in radians. Okay, and so it's really small to see, but if you look at your own paper, you notice that this mark is pi over 2, pi, 3 pi halves, and 2 pi. Okay, and this pattern would repeat on and on forever. So I want to give you just a brief explanation of where this comes from, and then we'll get into actually drawing these. So if you look at the unit circle, yeah, mine doesn't look like yours. Okay, I made this in 2013. Get over it. Notice that we're just graphing, or we're taking the easy points, is what I would say. We're starting at 0. Okay, we'll compare sine off to the side here. We're starting at 0 and saying, what is the sine value when the radian measure is 0? Okay, so the sine value here is 0. So notice that there's a point here at 0, 0. Okay, then we're going to the next easiest one, because, I mean, by hand, how are you going to graph some of these values? Root 3 over 2, root 2 over 2. I mean, maybe you get 1/2, but that's not, super helpful. So let's go to pi over 2, where my sine value is now 1. So over here on the x-axis, I'm going to pi over 2, and there's a point up here at pi over 2 comma 1. Okay, and you can see that this keeps going. When I go to pi, my sine value is 0, so you notice my graph comes back and hits the x-axis right there. After that, we go to 3 pi halves, and my sine value is -1, so you notice that the graph dips down here to -1. And then at 2 pi, we've completed the circle, so I'm back to where I started. And then the sine graph is created by connecting these 5 points. At least that's how we're going to approach it. And the cosine you could find the exact same way, just by looking at cosine values. That's weird lighting. So the cosine of 0 is 1, so this one starts up here. The cosine of pi halves is 0, so we get this point here. The cosine of pi is -1. The cosine of 3 pi halves is 0, and then the cosine of 2 pi is back to 1. Okay, so we've completed that full cycle by going around the unit circle. Now you'll notice on your notes there's this really cool Math is Fun website that has a really cool visual of what's going on. I highly recommend that you check that out at some point, and I might even show it in class next time. But it really helps you see how we fill in the gaps and all that. But basically, you need to know that they both have a wave pattern, and that the sine starts at 0, and the cosine starts up here at 1. It's going to be really important when we start to draw the graphs. Okay, now here's a table representation of what I was talking about. Now, the general equation, we've seen general equations before, where there are variables that take the place of certain parameters. So here we have a, b, and k, and where x is the variable, and cosine is the exact same way. So as we work through this, if I just focus on sine or Cosine's actually my personal favorite. I like it better. It's an even function. Sine is odd. I have enough odd things in my life that I just like some stability of an even function. So I might focus on cosine a little more. But these variables have some meaning, so let's talk about them. So the first one is the amplitude. Now, if you've ever, like in the music scene, you hear a lot about amps. That controls the volume and the loudness of the sound wave that's coming out. And so to change the volume, you change the height of the wave. Okay, so you'll notice that the amplitude is the absolute value of A. All of these, there's this important note here, we are still using transformations. So everything we did with polynomials, like moving left and right, up and down, reflecting, all of that still comes into play. Okay, so you can think of this amplitude like a stretch that we would have with an x squared or some other polynomial. It's going to stretch the wave out. So if just for example, if A was equal to 2, then when I draw my graph, instead of going up to 1, the cosine function would start here at 2, dip down, and come back up to 2, and it would, oh, I missed. But it would also go down to -2. So the amplitude is half the distance between the max and the min, meaning that if you go from this middle line, which is down here later on the page, you're going to go up 2 and you're also going to go down 2, or whatever that distance is. That's the amplitude. Okay, let me draw this in here. That's A. Okay, so then the period. Now this one we're going to talk a lot about, and so I ask you to bear with me on this video. I just don't feel like I can go into the detail that I want. So for now, suffice it to say, the period is how long it takes to complete one cycle. Okay, how long before the sine wave starts repeating itself. Now, you know from the unit circle, we talked about the property of periodicity, that after 2 pi radians, we start hitting the exact same angles again that we've already seen. So normally, the period of a sine and cosine function is 2 pi. All right, so you notice this graph here, sine, it goes up, down, and it's coming back up and hits the midline again at 2 pi, and cosine's the same thing. So to get the period, though, we look at the function and we take 2 pi, the original period, divided by whatever value we have for b. b is in here multiplying x. Okay, and here and here. So yeah, we'll go into more detail on that one later. Frequency, honestly, if you're not taking physics, you really won't talk about frequency. We will never talk about frequency, but it is just the reciprocal of the period. This we can use to find the number of complete cycles a periodic function makes in a specific interval. Okay, so period tells us how long is the interval. Frequency says here's an interval, how many times is it going to repeat in that distance. Okay. I should also mention up here on my graph, this is the period, so you start from here and you repeat period. Again, we could start at 0. Honestly, the period is anywhere that it repeats, so if I wanted to go on the sine graph, the distance here would also be the period because it's starting to repeat itself. Alright, so now the midline, that corresponds to our vertical shift. Write that out here. Vertical shift. So that's where, you know, half of the graph is above and below. Right here, the midline is at 0 for both sine and cosine. We can play around with that, though, by adding or subtracting k. Now this is in the same direction that you see the sine, so if it's plus k, I'm going to move up, and if it's minus k, I'm going to move down. We will talk about horizontal shifts later. Those cause a lot more problems. So the other thing to remember is that negatives are still reflections, which is why the amplitude was the absolute value, and the negative is going to cause a reflection, just like with polynomials. Negative caused a reflection, the coefficient caused a stretch. Alright, so that's just the basics and the vocabulary we're going to use. So let's start looking at example number 1. So identify the amplitude and period, then sketch one period of the graph. Do not use your graphing calculator. Helps if you can read it. I recommend you use a graphing calculator to check your answer, but do not cheat. All right, there are certain things that I'm looking for as far as work is shown and preciseness of your answers. So I know it says sketch, but we're going to be reasonably accurate here. So a couple things to identify, some scratch work first. Let's identify the amplitude. So we're going to start and we're going to say the amplitude is 2. Okay, there's no units on that, it's just 2. Next thing I want to look at is where's the midline. Okay, the midline comes from this shift here, that -1. So midline is going to be at y equals -1. So it's an actual line. So we want to put y equals. We don't want to just put -1. It doesn't really mean much. And you could say down 1, but I think it's just much more clear to specify where that line ends up. Okay. Now the next thing is the period. Again, I'm asking you to just trust me for a little bit here. So the period, as we learned on the other side, is 2 pi, always 2 pi, divided by b. Well, this time my b value is 3 pi. Okay, so I'm going to divide this whole thing by 3 pi. So we need to simplify that. Notice that the pi's cancel out. And I'm just left with 2/3. So my wave is going to repeat itself in a distance of 2/3. Okay, every 2/3. All right, so let's get to graphing this. Now, I just want to point out that we are only sketching one period of the graph. So all I care about is I'm going to keep everything positive. Okay, math has enough problems. We don't need negativity with that. Let's just stick with the positive. And I'm going to do this a different way than other teachers at our school. Okay, it works with my brain better. I like how it goes. I think my students have done okay with it. However, if you talk to your friends in a different class, they're probably going to know a different method. And if you like that better, I understand it. And that's the table method. But I like a more visual approach. So let's start by drawing in a midline. So I need to go down 1 here. And your scale can be whatever you want it to be. I'm going to make my -1 pretty big so I have some room to work with. So we're going to call that -1. And I really like to draw a dashed line. I like to see that midline. Okay. Next thing I'm going to do is I'm going to mark how high and how low I need to go to accommodate the amplitude. So the amplitude is up 2, but it's also down 2. Okay, remember it's the distance from the midline. So I'm going to go up 1, and then here's 2. So I'm going to go up to 0, then 1. So that's where my max is going to be. And then going down, there's 1, 2. So that's -3. My scale's a little off, but what else is new, right? Okay, next thing I'm going to do is I need to mark where my graph is going to end. So we're going to come out here somewhere. Again, you can set the scale however you want. I'm going to put a mark right here. I'm going to call this 2/3. Okay, that's where I want my graph to repeat, or start repeating, is right there. Now, we need to figure out 5 key points. We already have one of them, 2/3. I want you to notice when we were going over the front page that disappeared somewhere. Ta-da! When we talked about this graph, I pointed out 5 major points, the easy ones. Okay, when x is 0, pi halves, pi, 3 pi halves, and 2 pi. We're going to take that same approach of finding 5 points and then just connecting it in a wave pattern. Okay? Now, you'll also notice that these are all equally spaced. These waves have symmetry to them. They have odd and even symmetry. But no matter what, no matter how much we compress the wave or stretch it out, these points are always going to be equally spaced. They might not be pi halves every time between them, but whatever the distance is from this first point to my second key point, to the max, is going to be the same as the distance from the max back to the midline, from the midline to the min, and the min to back to the midline. Okay, those distances are always going to stay the same for every graph. Well, per graph. Within a graph. I hate English. You get it. So what I need is so my first point's obviously going to be here on the y-axis. So there's a second point. What am I doing? Yeah. Third, and a fourth and a fifth. So I've got the axis here, 2, 3, 4, 5. Okay, 5 key points that are very evenly spaced, as you can tell. So the next thing to know is we have to look at sine and cosine, and you have to know, like I pointed out, that sine starts here at its midline. Okay, the midline is cutting it in half. Cosine starts up at its max value, and then comes down. So when I'm looking for key points, and I look at the sine graph, and I say, all right, sine has to start on its midline. Well, the midline's now at -1, so when x is 0, sine is at the midline. So there's a point right there. Now I'm getting ahead of myself, as I usually do. I even tried to plan this out. Like, I did this example on another paper, and then I put that paper away, and I'm not even looking at it. Go team, go me. Before I get to actually plotting the points, I need to figure out what these are. I do expect you to have these values, because since I'm letting you choose your scale and make this as big or as small as you want, and I'm not giving you graph paper or anything like that, I need to know what your values are. Anyone can draw a wave shape, all right, and call that sine. So I need to know where it is and how compressed or spread out this thing is. So the way I think of it is, notice that there are 4 sections. There's 5 lines because I'm using the axis, but there are 4 sections to look at. I need them equally spaced. So I need to take this distance of 2/3 and divide it up into 4 pieces. Okay, and sometimes that's easier than others. This one's a little tricky, okay? But if we come off to the side and I say 2/3, and I'm going to divide that into 4 pieces. Okay, a little work with fractions. This is the same as 2/3 times 1/4. Okay, multiplying by the reciprocal, so I get 2/12, which simplifies to 1/6. So what that tells me is that every piece needs to be a distance of 1/6. Okay, so I just start counting. This is 1/6. This is 2/6. 3/6. You could call it a half if you want, but 3/6 is fine. And then this is 2/3, but if you think about it, I should be at 4/6, which is the same thing as 2/3. Okay, so I've cut it up into equally spaced segments, and now is the easy part that I was trying to jump ahead to. It's actually graphing this. So notice over here, sine starts at its midline, and it goes to its max. And I don't have any reflection, so I'm going to follow the same pattern. Okay, so at my next section over, I need to be up here at the max. At 1. Alright, and then the next equally spaced section, I'm back to the midline. So I'm over here at 2/6, I'm back at my midline. Okay, in my next equally spaced section, I go down to the min. So I'm going to go from here, go all the way down to -3. Again, please disregard my scale, as you should be used to doing already, since you've seen me write on the whiteboard. And then I'm going to come back to the midline to finish it up. Okay? Those are my key points. And then everything after that is just connect the dots. Everybody's favorite game since they were 3 years old. There we go. That's one period. Okay? That is, and it would just keep going in that same pattern, which is why we only look at 1. So I'd be done. Now, I need to see your work. There's things that have to happen. I've got to see these marks. Alright? You cannot just put marks and say, oh, here it is, and it follows this pattern. Got to see the marks. I need you to identify the amplitude, the midline, and the period, like it says in the instructions. And then if there's any scratch work, please show me that. So this would be good. Complete a problem, and then if you want to check it on your graphing calculator, feel free. Okay, that was probably really fast. But we're going to keep going. This one's going to be even faster because I have a feeling this video is going to go long. Surprise! So let's identify some stuff here. Let's do our amplitude. Amplitude is just 5. Remember, it's the absolute value of this a, this coefficient. Okay, that negative does something else. We'll address that in a minute. Midline. Okay, this one went up 3, so I'm going to say it's at y equals 3. Period is 2 pi divided by 1/2, that coefficient on the x. So that's the same thing as 2 pi times 2/1, which is 4 pi. Why we couldn't start with a simpler example, I don't know. But we're better people now because we started with 2/3. And then something else to notice is we need to say that there's a reflection. And I often forget about this, so hopefully, okay, knock on wood, that I don't forget it because I'm writing in pen. So that this negative right here caused a reflection. Alright, here we go. Let's draw a grid, again, sticking to the positive side. Midline's at 3. I'm going to shrink this one down a little bit. So there is 3. Here's my dashed line. My amplitude is 5, so I need to go up and down 5. So 1, 2, 3, 4, 5. Puts me at 8. Down 5, 1, 2, 3, 4, 5. Puts me at -2. I do need to see those labeled. Alright. Period's 4 pi. Super nice. Okay? Come out here. We're going to call this 4 pi. I need to cut 4 pi into 4 even sections. I'll give you a second to think about that if you need it. Okay, that was a lot of seconds, but we all should know that if I cut this into 4 equal sections, each of those sections is now pi. So this is 2 pi, 3 pi, 4 pi. Don't forget to bring pi on March 14th. You know, just putting a plug in there. All right, this is a cosine function. All right, so I know that I'm going to start at my maximum value, except, almost forgot, there's a reflection. So let's bring cosine back over here. Okay, if I'm reflecting this, that means reflect over the x-axis, so everything's going to flip. So instead of starting at max, this is going to flip down to the min. So I'm actually going to start way down here at -2. And then I'm going to come up to the midline, and then up to the max, and so on and so forth. So cosine, again, we go max, midline, min, midline, max. So I've got, with my reflection, the minimum up to the midline at pi, up to the max here at 2 pi, back to the overly spaced 3 pi midline, and then down to the min at 4 pi. Get out of here, 4 pi, you're in the way. Now this one, please don't make it look like a V. Okay, it's also not a U. I want you to notice this. If I cover up this side, it is a slightly bell-shaped, flower-shaped. You know, there's some sort of flower that opens up like that. But it's not a V, and it's not exactly a U either. Okay, so it comes out, goes up, comes back around here, and flattens out. Okay, there we go. We're done. So, moving on from my Christmas colored page, we have this one. I love this page. A lot of people struggle with it, so hopefully we can conquer it together. By the way, I was totally considering putting that song Waves by Mr. Probs in the background while I did this, and then I got scared of copyright infringement and all that stuff, and my awesome video that's going to get, like, who knows, maybe I'll break 40 views on this one, might be taken down, and that would be sad, so I didn't. But that's the song that's playing in the back of my head this whole time, and now it's going to be in your head, and it's going to get stuck there like it always does, so you're welcome. Anyway, identify the amplitude and period and determine where the midline is located, then write an equation for the function. Alright, so first thing is when this says use sine, since sine and cosine, if we didn't tell you that, it could be either of them, and you just, do different types of shifts and transformations. So since it is at sine, we know that it's going to start at its midline. Okay, and also you can just kind of tell that this line right here at y equals 2 is cutting it in half. There is an equal amount of space above and below, which means the distance from the top to the bottom here, that's a, which happens to be from 2 up to 5. So put my amplitude. My amplitude is 3 from 2 to 5. My midline is at y equals 2. Okay. And then the period. So this one I don't have to do any division yet. Period is how long does it take to repeat. Okay? So here I go down, I go up. Now, I'm crossing the midline, but notice when I started I was going down and now I'm going up. So that doesn't count as a full cycle. So I go up, and now I'm coming back down again, and I cross it again right here. So if you look, their scales are off to the right. So this is actually 2 pi. Alright, so from 0 to 2 pi. My period is 2 pi. Okay, so now we need to plug this into an equation. Now, biggest mistake that happens. I usually don't like to do this on videos, but I'm going to write something that is wrong. Oh yeah, I'm missing something else too. Every time. You guys never call me on these mistakes. There's something else wrong here with sine. Okay? If you look back at the original and compare it to this one, they're off. Sine normally starts by going up. This one's going down. So there is a reflection that I need to be aware of as well. Okay, now I can write the function. I just get so excited about these functions. I just can't wait to write them. Get ahead of myself. So there's a reflection. We're going to start with negative. By the way, here we go. You don't have to write this. This is wrong. Okay? Bad things. A lot of people write this. 3, well, negative 3 sine of 2 pi x plus 2. But Mr. Arthur, why is that wrong? Well, it's wrong because the period is not what shows up in the equation. Okay? Nowhere, on our previous pages, okay, the period here was 2/3, but there's not a 2/3 in my equation. Likewise, the period here is 4 pi. There's definitely not 4 pi in that equation. So what goes in the equation is the b value, not the period. The b value is a tool for finding the period. So we're going to use big red pen, which you're taught in teacher school. You should never use red pen because red pen hurts students' self-esteem because they feel bad when they see red. So you should use other colors. Well, I'm using red because we're not doing that. Instead, I use green for go. This is the right way. Okay. We are going to start with negative 3 sine of something with an x in it plus 2. That stuff's really straightforward. Now, to solve for the b value, you might need to do a little scratch work. Come off to the side, and we know that formula that period equals 2 pi divided by b. Well, this time we don't know b, but we do know the period. So I can plug in the period, that's 2 pi, and it equals 2 pi divided by some b, and then we just solve for b, which this one's really lame because it has to be 1. Hopefully you can see that. The only way to get it equal to 2 pi is to divide by 1. So b equals 1, which means I really don't need anything in here. I could just say sine of x. You could put a 1, but you don't have to. So this would go up here. So my final equation, just because that space is bugging me, negative 3 sine of x plus 2. Probably should put f of x because it's a function. Please watch out for that period though, okay? You plug in the b value, not the period. I think this one will help us see that a little bit better. Let's identify some things again. So it doesn't really matter what order you start in. I always start with the amplitude, but you have to know where the midline is to find the amplitude, so it's kind of weird. That's just what I do. There's my midline. Cuts it in half horizontally. So amplitude is 1. Okay, we're going up 1 and down 1. I'm using cosine. Midline is equal to y equals -4. The period. So let's see, from here, from 0 to repeat to that next peak is pi. So my period is pi. And this is cosine. So cosine normally starts at its max, and this one is also started at its max. So there is no reflection. Okay. So let's put this together. Amplitude is 1, so I really don't need to write anything there at the beginning. So I'm just going to jump right into the cosine of. Now, let's figure out what the b value is. So before I finish writing that, I'm going to say, again, I know that the period equals 2 pi over b. My period this time is pi, so it's pi equals 2 pi over b. And you can multiply by b and divide by pi if you really would like to. But hopefully you can see that if b equals 2, then the 2's will cancel out and I'll just be left with pi equals pi. So b value is 2, x, and my midline I went down 4. Okay. There's my function. Yay! Alright. Last page. I'm sorry, I feel like this is going really long, and I'm the one doing the talking. But it's not the easiest of sections, so I apologize for missing. So let's talk about a horizontal shift. Okay, we call these phase shifts, which is really cool because it sounds all like sci-fi and stuff like that. So phase shift. So the general equation here is that we have still the b value and then x minus whatever. Please remember the backwards x's, just like when we were doing things like going from x squared and making that x minus 2 squared. And so the transformation here was to go right 2. Okay, same idea here. If I'm subtracting a number, I'm going to actually move in the opposite direction. Okay? Now, I also want to point out that this b is multiplying the x and the phase shift. That's going to be important in our second example. But let's do the first one first, because everybody does that. It's actually impossible to do. Never mind. It's late. I really need to go home. So, amplitude 3. Okay, midline, it's up 1. Midline, y equals 1. Alright, the b value, it's nice and separated already for us. So, for the period, I'm going to get 2 pi divided by 2. Cancel those out, so the period is pi. The phase shift, which I just write ps, is going to be to the right. It's important to put a direction. Pi over 4. If you just put pi over 4, you're going to miss some points because I don't know if that's right or left. You have to know whether that's right or left. And there was no reflection. Alright, so I'm going to take the same approach. I still don't want to use, I'm not going to do the table. Let's identify a midline. 1, 2, 3. Okay, here's my midline at 1. Amplitude is 3, so I need to go up 3, so that's 4. And then don't forget to count the axis as 1, so that's 1, 2, 3. So there's, wow, -2. I caught that before you could say anything. Just saying. Now, the thing that is different, let's do this in red, is that I am no longer starting at the y-axis. I have shifted everything to the right, pi over 4. So I'm going to call this point here, this is pi over 4. And I'm going to put another imaginary line here and say that's my new axis. That's where I'm starting from. Alright? So my period is pi. Now, I can't just come out here and put pi anymore. The period is the distance from where you start to where you end. Okay, now when you start at 0, you can just mark the period as it is. Drop my pen. But since I'm starting at pi over 4, I need to go a distance of pi beyond that. So, you might be able to just see it. If not, you can say, okay, pi over 4 plus pi. Well, pi is the same as 4 pi over 4, so pi over 4 plus 4 pi over 4 is equal to 5 pi over 4. Probably got there already anyway. So that's where I need to end. So I'm going to come out here, and this is going to be 5 pi over 4. And again, the reason for that is that I have to have a distance of pi, my period, from where I start to where I end. Okay? Then everything else is the same. I still need to divide this up into 4 equal sections. 1 section, 2 sections, 3 sections. And this one's really nice, because to go from pi fourths to 5 pi over 4, you're just counting by fourths. So this is 2 pi fourths, 3 pi fourths, and all of a sudden I'm changing my fraction style. So for the OCD people out there, I'll make this 4 pi fourths. Okay, and I don't care if you don't simplify those. It's fine if I can see your pattern of reasoning. So I've got those marked. It's cosine. I haven't reflected, so that means that I'm going to start up at the max, okay, at my new axis, so I'm up here at 4. Alright, then at the next point, I'm at the midline, then I'm at the min, then I'm back to the midline, and then I'm scrunching in the last point, back up at the max. Okay, again, don't make it a V or a U. Make it some weird hybrid. And there's my graph. Okay. Last one, the end is in sight. I don't have a timer on this, but I'm betting that I've already broken 40 minutes. So, let's identify some things. Let's do the amplitude. So there's nothing in there. It's just a negative. So my amplitude is 1. So it hasn't changed from the original. Let's do the midline. That is at y equals -2. Let's do the period. Now this is where things get a little tricky. You will be able to get by saying that the b value is 1/3, because it is. However, notice that when we have the b value, it needs to be multiplying the phase shift. Here I have no parentheses, and no, you better not just throw parentheses around that x plus pi. Okay? That's right, I'm shaking the finger at that. So, instead we need to just do some factoring. Okay? I want to rewrite this as negative cosine of, I'm going to factor out the 1/3, so I get x plus 3 pi minus 2. Do you see how if I distribute the 1/3 to the 3 pi, I get back pi? So my phase shift is actually 3 pi to the left. Okay, so that we got to be careful there. So I'll take that. So let's do 2 pi divided by 1/3. Same thing as 2 pi times 3 over 1. So I get 6 pi. My phase shift now, that we already identified, was 3 pi. Oops, it's plus, so I need a left. 3 pi. And there is a reflection, so I want to make mention of that. Cool, let's go to town on this one. So I'm shifting left 3 pi, which tells me I probably want to get some space over there in the negative land. But my period's 6 pi, so who knows, this could be pretty stretched out. Alright, so my midline is down at negative 2. 1, 2. Oh, that's lame. That's going to be the tiniest. Okay, pretend that's not there. That's 1. That's 2. Negative 2. Okay, so my amplitude is 1, so I'm going to go up to negative 1, and I'm going to come down here to negative 3. Cool. Now, let's shift over 3 pi to the left. And I'm going to call that wherever I want to call that. This is now 3 pi. Negatively. Negative 3 pi. Okay, so here's my new axis to start from. Okay, now the period is 6 pi, so I always go to the right. So if I go 6 pi to the right, that means I'm going to end up over here, ending, let's go above, at 3 pi. So negative 3 pi plus 6 pi gives me positive 3 pi. So like I said, this one's pretty stretched out. Now, we got to cut 6 pi into 4 equal pieces. That's kind of tough. 1, 2, there we go. Well, actually it's not as bad as I thought. So 1, 2, 3, and 4. 1, 2, 3, 4. Okay, so if you need to, off to the side, you can say, alright, 6 pi divided by 4. Well, that's just a fraction that simplifies. Divide them both by 2, you get 3 pi over 2. So every section, I'm moving 3 pi over 2. So we got to be careful that I not just label it 3 pi over 2, but that's the distance that I'm traveling. Okay. So that's also like saying 1.5 pi, if that makes it any easier. So this, if I go 1.5 pi to the right, I am at negative 1.5 pi, or in other words, negative 3 pi over 2. This one's obviously at 0. It's nice that it's symmetrical, because that tells me that this is also at 3 pi over 2, and then 3 pi. So things kind of worked out, you know. It's like we thought about it, we planned it, and made it look nice. We do that once in a while. Alright, so those are my points. This is cosine, but it is reflected. So instead of starting at my max over here, I'm going to start at my min. So right there. Okay, I'm going to go to the midline at my next mark. I'm going to go to my max at the mark after that. Come back to the midline. And then finally back to the min. So this one's pretty stretched out. Just make sure it's got a curve to it. And there's my graph. Whew. Alright, we made it. Clear as mud. Hooray! So please rewatch this if you need to. Please talk to your friends and get these steps down. There's a lot of steps. I didn't list them out, but you can do it. Alright? Best of luck, and I will take all your questions when I get back. See you on Pi Day. Don't forget pi. Everyone loves pi.